today I have a FESTO stepping motor with absolute BiSS encoder and some cabling to a TEL. So that's a Copley stepper, StepNet, Ethernet. I thought it was a single turn because there's no battery, but as it turns out, this is a POSITAL FRABA multi-turn, and there's no battery. So that's the Wiegand effect again for multi-turn. 17 bits, single turn, 16 bits, multi-turn. We'll take a quick peek at what we got going here. The FESTO stepping motor with feedback. There's the connector on it. I just took a couple of screws out to take a look at the feedback device. So POSITAL FRABA. So we have the motor here, millimeter 57, kilograms, centimeters squared, about 0.3. Speed torque curve. On 48 volts, you could hit about 1,500, but I've got 24 volts, so 120. Well, so they're saying at no torque. Yeah, okay. So yeah, as for 500 RPM, no problem. Then you start rolling off, and maybe you get there, maybe you don't. But 48 volt would be the ideal voltage, or you could use 80 with a Copley and get, ridiculous speeds out of here, according to this. Oh wait, there's different models. Yeah, there's the slow one, the -L. I think that's what I got here. Anyways, we can take a look at the specification for the motor. So this 45 is a multi-turn, absolute multi-turn. Okay, we're getting there. Here we go. Okay, so we've got 5 amps for the -L, 1.8 Newton meters, peak torque 2.1, top speed, but it also mentions this for the top speed with the M instead of the no. Torque constant, 22.6 millivolts per minute. That's like 1K RPM for 24 volts. Perhaps, maybe not. It says 500 RPM here. So anyways, resistance 0.26. I measured about twice that. So that's a series or parallel, just one coil. So they probably wound it in series or parallel for more torque, less speed. Inductance or the inductance or the inductance. Winding series inductance. Phase. Unlinked. Okay, so I'm saying it's about 2 millihenry, and the current loop looks pretty good. So a quick peek. Yeah, TEL, hook up the feedback here, power 24, 48, up to 80 volts, UVW, A naught, B naught for the motor, stow bypass jumper, serial port, Ethernet port, alias, and buffered output if you need encoder counts emulated, and a brake output. The motor doesn't have a brake. The POSITAL FRABA, we took it apart, took a look, and we got this this part here, BiSS. It's the probably this one because I'm running it at 2 or 4 megahertz, so it doesn't do the low frequency. That's fine. We do high frequency. Yeah, top speed lasts for 20 years. Mean time to failure. 17-bit single turn. The 1616 is 16-bit multi-turn, so that's good. Connector, blah blah blah. I don't know. Pin 1 was over here, I think, and then 8 was 5 volts. Let's take a look at that. The wiring is very important, and so are the colors. So on the motor, we got the white wire, which is plus, so that's pin 8. So pin 1 is over here. So pin 1 is brown, which is 0 volts, and then gray, yellow for data plus, data minus, violet, pink for master minus, master plus. Okay, so just be careful you don't get these swapped around. A little bit of an unlogical order, but there it is. Okay, so going from this cable to this connector, don't look at the pin out there, but you can see like here's the wires coming from the POSITAL FRABA going into the back of the connector on the motor. Anyways, so the white wire becomes the red wire going to the cable and the drive. The pink becomes the gray, the violet becomes the pink, the yellow is the yellow, and the gray is the gray, and the brown is the plus. And then when we get over here to the FESTO connector, don't read these pinouts here because they're looking at the not where the wires go in the back at the numbers, but in the front, and you change your perspective. So pin 12 is 0, and pin 11 is +5. So ground +5, so on and so forth. Anyways, to go from the 0 volts, it's blue, signal ground, red wire, it's +5 volts. I got the clock on the gray and the pink, and the data on the purple and the violet. And just to make it look simple, something like this, motor, something like this, and that's good. So let's look at CME. So I got the TEL with factory firmware, 4.36 at the time of this video. And I'm using CME version 8.1, beta 31, beta 30 is on the web. Release candidate should be released by end of 2024. It's a rotary motor. There's no brake. It's not a vertical application. It's a BiSS on the motor. You could have like BiSS on the load or something, or BiSS on the motor, BiSS on the load. Anyways, right now I'm not doing encoder corrections. We'll take a look at that in a minute, but if we make it there. But it's 17-bit single turn, 16-bit multi-turn, BiSS-C. No alignment bits, just standard POSITAL FRABA multi-turn. Wiegand effect, no battery. It remembers by turning the motor shaft. You get a little charge, which turns on the flash, which remembers the position in the motor, in the feedback. That's very cool. So I'm doing 4 megahertz active low. This is the default, like just hit the default button, position status alignment. Servo, don't do current loop rate in the position mode. So next, don't ignore your feedback unless there's a bolt of lightning, maybe 3 ignores, but fix the cabling, grounding, shielding problem. If you do have a problem, I didn't have a problem. If there's a break, come to a controlled stop, nice and safe. If you don't want to do just a safe stop, you got to put in a time it takes to stop, a speed at which it's okay to then wait and then disable and then cut the stop. So that's in conjunction with input 1 is hardware enable. This is an EtherCAD, or Ethernet would be software program, but I got the Ethernet firmware in here from the factory. And you could emulate out or take step and direction in. Okay, so that's all set. Say okay, saves to flash, enter the data, FESTO. There was 2 part numbers, so I put them both in there. This is the manufacturer's part number, made in Eastern Europe. Kilograms, that was 0.3. 0.6 ohms, 1.75, took it from the data sheet. 5 rated. When you go fast, this will fold back. 1.8 degrees. And you set the micro steps to the same as the feedback. 2 to the 17 is 131072. And you can see that here, 131072. And then you calculate the initial tuning parameters. And I didn't make any, oh, I did make a change. Yeah, 0.3. Let's say flash. Okay, so the I loop, the bandwidth made the motor shaft turn, so it didn't get an accurate reading. So I'm just going to do my own tuning of the current loop. I put in 0.5 amp, auto setup checkbox, hit start. I changed the gains, brought CP up from the calculated value to 400, so it was pretty close, and then CI to 40, and looks like, you know, good step response, not excessive bandwidth. Okay, so let's not go for excessive bandwidth. Anyways, normally we do auto setup for the profile and we put in a relative distance, 131072. That's 1 rev. Profile velocity, there's the actual current and the commanded current. There's the bus voltage, which is 24, and the back EMF voltage at the speed. And we're going to go 500 RPM. That looked good. And we're going to monitor the following error. So let's take a look at that. So normally the following error, let's disable, enable, set 0. All right, enable checkbox. I was in a stepper mode, so I can set 0. Commanded position. I'm not really going anywhere yet. Anyway, so the limited and actual position, and we'll look at this as the following error. Okay, so right away, like even when I set the position to 0, it's plus or minus some noise, right? So few counts, it's 17 bits of lots of stuff, and even when disabled, it still counts. It's quantization, right? That's what it is. And so when you enable, disable, the motor moves a little bit, it pulls to a pole position, you can see the counts. It's open loop, but there's no difference between, not much difference between the command and actual, but that's, resolution. Anyways, gonna make a move, and you see 131072. Well, we could move to 0 first, so let's move to 0. So rewind the motor to 0. And let's do 131072. Zing. Okay, it makes the move. And you can see here in the graph, accelerate, run, decelerate, stop. When you hit this speed, about 400 RPM, you start to fold back. I got 24 volts here in the orange. And you can see the magenta is building up to like 24. Whoa, it's hitting the voltage limit. Okay, so 48 volts if you want to go 1,000 RPM. That's what the note said about 500 RPM. I mean, you still got some torque. There's still some current. You got 0.27 amps, so you're folding back, just like on the graph. And the following error builds up and then comes down. And then when you go from run to hold, like 5 to 3 point something, whatever the hold, you see a little change in counts there. And that's based on the change in the current. It's okay. We turn on encoder corrections. That won't happen. And homing, of course, it's absolute immediate home. Absolute active immediate home. You can do an offset. I just rewind the motor to 0. Okay, if we still have time, which we don't, we'll do the basic setup, change settings, and we'll do, where's the encoder correction? Encoder correction. And so now with an ECP, we should see the counts lining up, see the errors maybe is, well, let's make a move first and see. Okay, so that's with ECP turned on, encoder corrections proportional. And now you can see we're working on the error coming down. It's bringing it down while it's moving, and then it brings it down after it moves. So we're back to 0 following error. And there's a little few count hiccup there when the current transitions, but that's what encoder corrections does. You can try more gain. If there's too much gain, it might get buzzy. And oh, that was buzzy. Okay, let's just try 50. And yeah, so very, very good at 0. And now, yeah, so encoder correction, proportional gain. When the gain's too high, it gets buzzy. That one worked. So I just double and find the point of oscillation, cut in half. It's a little, buzzy, but it's plus or minus 5 counts. I'm just going to take it back down to 50. This will reduce the settling time to get to the last count. So there we go. You can, if you like the picture, you can save it to a file. That's a scope trace. And then after you're done, save to flash, saves all your changes. File, save CCX file. Do I have a FESTO? No. Let's create a FESTO. Now I'll just say FESTO. So we can drive FESTO motors, no problem. F-E, FESTO. And I don't know, put the